conferences instituted around the world. May I please take this opportunity to present this project before you all. Space mission requirements, the hypothesis of Aryabhatta, mission objectives and mission performance. Then I will just give a small brief on mission designing and operational activities, and then after I will switch to potential applications or any other planet, such for mineral resources and space tourism. If we'll talk about economic, and there is also a need for the economical to shift the satellite orbit from one planet to another one with the using unmanned space vehicle. The basic requirement to deorbit the satellite are flight testing of electrical and propulsion techniques, along with other deep space technologies by performing the scientific observations of the planet. For example, if we are to perform scientific observations on Moon or Mars, we need to change the orbit of the satellite, existing satellite, which is revolving around the orbit of Earth. This conceptual diagram shows the basic fundamental basic parts of the Aryabhatta vehicle, which includes multicrystalline solar panel, payload unit, control unit, power propulsion, and OMS buckets. Solar powered USV, that means unmanned space vehicle, which we refer as USV, with having arm propulsion system along with a solar electromagnetic propulsion system. It will be placed in rocket boosters and it will be sent just like the normal traditional launchers. USV will also be having arm propulsion system, so that xenon cylinders are required to provide the further power for further information. Now the satellite, which will be attached with the space vehicle, this USV, by a robotic arm. It will shift the orbit of the particular satellite, and by using its OMS and main thrusters. Now for that, electricity will be generated by the solar panels, which are made up of multicrystalline solar cells, and the USV and the energy which will be stored in the payload unit in the lithium-ion batteries. Now I will also discuss later on about power management, how the power is getting to be produced and stored. Now, all operational activities will be controlled with the equipment of navigation system controlling, especially by the commanding of dual band antennas. As we all know, ion propulsion is a technology that involves ionizing the gas to propel a spacecraft. If the probe carries a larger solar array, certainly would have a slightly higher acceleration, and if it carries more xenon propellant as well, it can reach the much higher final velocity by simply thrusting it along. The solar electric propulsion takes advantage of magnetism and electricity to push a spacecraft through the space. Electricity, which will be generated by the solar panel, gives a positive electrical charge to the atoms inside the chamber. They are pulled by the magnetism towards the back of the ship, and thereafter pushed by using the magnetic repulsion out of the ship. 2 and 6, acting in opposite directions, provide the pitching moment. For this maneuvering, engine 1 and 2 should provide a total equal power output as engine 6, which is over here. And the same applies for the opposite movement, which engine 1, 2 and 4. From the design of OMS system, it can be concluded that the USV is capable to have 6 degrees of freedom on its best possible thruster engine positioning. And what we conclude for the OMS is that it is required to do a good study in more depth and understanding it on the particular considering the particular satellite requirement. Now the following chart shows the power management of the USV. The power which will be generated by the solar panel, it will be stored, it will be go towards the DC motor. From the DC motor, it will be stored in the flywheel. According to the requirement, the power will be released from flywheel to the generator and will be fed to the power processing unit. But we can came up with conclusion it's best outcome for the solar electric propulsion. The following result show we use the MATLAB coding. We develop a mathematical model to do simulations with delta V and payload system mass considering the time of flight. Now we targeted mass initially. So we did the calculations using the escape velocity and launch window analysis, and we came up with this result for the orbit trajectory, orbit transfer trajectory from Earth to Mars. Now if we launch a spacecraft from Earth to Mars or any other planet using the least propellant possible, first consider the spacecraft is already in the solar orbit when it sits on the launch pad, as we all know. This existing solar orbit must be adjusted to cause it to take spacecraft to the planet. The desired orbits, perihelion or periapsis, will be at a distance of Earth's orbit, and the apoapsis will be at a distance of Mars or any other planet, considering Hohmann transfer. Well, the spacecraft is, once it has periapsis, so the spacecraft lifts off of the launch pad, rises above the Earth's atmosphere, and uses its rockets to accelerate in the direction of Earth's revolution around the Sun, to the extent that energy added here at a periapsis will cause its new orbit to have an aphelion or apiapsis equal to the targeted object or targeted planet. So the acceleration is tangential to the existing orbit. Now after this brief acceleration away from the Earth, the spacecraft has achieved its new orbit and simply crossed the rest of the way. Getting to planet Mars, rather than just to its orbit, requires the spacecraft to be inserted into interplanetary trajectory at a correct time, so that it will arrive at the Martian orbit when the Mars will be at a particular position. Now, we can have two launch window analysis for launching spacecraft in interplanetary missions. We come up with a launch arrival date that gives a single unique trajectory solution that's basically based on a random calculation. To be captured in the Martian orbit, the spacecraft must be decelerated relative to the Mars using a retrograde rocket gun or some other means. If you want to land on the Mars, the spacecraft must decelerate even further using a retrograde gun to the extent that the lowest point of its Martian orbit will intercept the surface of the Mars. Since the Mars has an atmosphere, final deceleration may also be performed by aerodynamic braking, direct from the interplanetary trajectory, or using parachute or for the rocket retrograde guns. This project, we are going to further development in the project. Will not only, and it will succeed, it will not only help to change the orbit of a satellite from one planet to another, but it also eliminate the need for sending extra space probe for any mission observation and data collection of any planet. Solar electric propulsion would make such a mission possible because an ion engine can run almost continuously and outperform any chemical rocket for such long flights. And the most important, we can subsequently we can also reduce the problem of space debris up to certain instant. So there is a lot of we have to do right now, but still more depth. We'll try to come up with a firm project proposal to the space agencies. Thank you all.